This is contract J108. The client for this project is Land Transport Authority of Singapore. This is an initiative by the government to facilitate all the people in terms of transit in Tengah, this new town. So the completion of this MRT will be between 2027 to 2029. It was awarded to our main con, John Holland, McConnell Dowell joint venture on March 2020. And their major scope includes construction, design, and completion of 3 elevated stations, including 2.3 km of elevated MRT viaduct. The joint venture has awarded VSL as a specialist contractor in September 2020 to complete the erection works. So VSL major scope includes design, fabrication, and provision of erection equipment. Currently, we have approximately 12 staff, which includes managers and engineers, and around 60 crews, which includes supervisor, foremen, and workers. The progress of the job, we have completed 40 span-by-span, 30 via LG2, the span-by-span gantry, and 10 via the combo gantry. Currently, LG1, the combo gantry is ongoing, a balanced cantilever construction. We have erected 604 segments out of 1,344 segments. This is around 45% of the job completed. We are targeting to complete the erection work by March 2025.
In post-tensioning, this bridge is actually the first one in Southeast Asia where we implement the segmental coupler technology, which is allowing basically to go to a PL2 level of protection. So that required quite a lot of challenging and a lot of coordination with the precasting team, with the casting cell designer, with the permanent works designer, because all these segmental couplers, they required a lot of effort at the beginning of the project to get all parties aligned. So in terms of erection equipment, we are having 2 launching gantries, 4 lifting frames, 2 hanger beams, and various other secondary temporary works. We are doing almost everything which is possible to do in segmental erections, because we are erecting balanced cantilever with launching gantry, we are erecting span by span, we are erecting balanced cantilever with lifting frame, erection and shoring. One of the technical challenges that we have here is that this bridge is very, very narrow. We are erecting segments which are only 3 meters wide, so that creates a lot of problems in terms of access, in terms of space. So we have to go to a very, very compact design, and that's what's pretty challenging. On top of this, we also design all the temporary post-tensioning, which is required for all these balanced cantilever erection for under the temporary stages. So which is including temporary PT bracket, blisters, and a few precast beams that we have to implement also on the site.
My team has collected the data in a daily manner, which includes the photos of each activities. Mainly, we are focusing on the 2 LG activities, so the data are then later input to the Excel spreadsheet and then plotted as a chart and submitted to my client in a daily manner. With the data that we collected, we can further study the productivities that we have. The BMO team has recommended the data to be digitalized, and we have used Quick Connect to register the similar set of data that we have recorded in the daily report. The data that we have collected through Quick Connect is being transferred to Power BI and plotted the similar graph as what we have achieved from the Excel spreadsheet. On top of that, we have put in sensor to our gantry, and the sensor are recording the activities that we have. These data are being cross-checked together with the data which we have collected manually to check the accuracy. As for BMO, our target is mainly on the span-by-span erection with the LG2.
We have a baseline program. We giving the main contractor is 4.5 days for the span-by-span erection. We're doing the segment liftings 1 day, and then we're doing the gluing is 1 day, and then we're doing the post-tensioning work is 1 day, and then we load transfer, span load transfer, and then sliding is 1.5 days. We are now is achieving the target, and then we have the span by span is launching is 3.5 days. Is 1 day is we launch the main truss, and then second day is relocating the ULRS, and then third day we disengage the support leg, and then we launch and then slide back to the push shaft.
We have presented the progress to the BMO team to set new targets to improve the span by span erection to something which is lesser than 4.5 days. The current target is looking at 3.5 days instead of 4.5 days.
The technical team was integrated in the BMO process since day one. So we have a lot of discussion with the production to make sure that we identify all the tedious activity and we find a way to improve, accelerate all this one. As an example, we have equipped all the launching girder with counterweights which are helping to manipulate the bars a bit faster. We have implemented twin jacks which are allowing to hang the stress bar from the side, so with less manipulation they're a bit more ergonomic. Recently we have designed a specific tool to be able to manipulate the post-tensioning jacks inside this very tiny box. So that was really a full integration since day one to make sure that all the tedious activity, we try to anticipate them as much as we can from the technical side to help basically the production to achieve their target or to exceed basically the target cycle.